Hi everyone, I'm Srisha. This video is just to try to demonstrate a small AI LLM. Okay. So what we're gonna do is user gives some prompt like sentences, and we have set of our statements. Okay, set of our sentences which are already defined, and we'll convert both of them into a mathematical form and compare using some mathematical operation and see which of those has more weights and return that, assuming that is a good match. Okay, so any data like which can be described using mathematics, right? So we are just using mathematics to find the best match for this. Okay, so what we're gonna do is we use Java to do these operations. So we'll create to mainly two functions. Okay, text to vector and to find the similarities. So in this particular function, right? So we will we will try to create every data, every sentences using including the user prompt to a mathematical data type called a vector, we'll call it here. Okay, to do that we are using some already inbuilt keywords called vocab. Okay, so we will convert each and everything to a vector form. After converting, we'll use another functions and find the best match. Okay, find the best match using first sentence, second sentence with respect to the user prompt, and whichever gives the highest value will be returned as a good match, right? So we will understand when we go into the program. Okay, so in this program, right, the vocab. Okay, this is like the set of all keywords. Okay, we have defined here the keywords, and these are like file 1, file 2, file 3, file 4 are something like the trained data or the existing sentences. Okay, and this will be the user prompt. Okay, yeah, we can accept directly from the user, but say for simplicity I have done this one. Okay, so whenever the user gives the prompt, where is the cat? So out of these four sentences, the best appropriate sentence is the cat sits on the mat, right? So when I run this program, right, yeah, we'll get the output as best match. Okay, here is the user input, and this will be some calculations result, and the best match is the cat sits on the mat. Okay, this is coming from mathematical operations. How we are going to do this? So as we know here, keywords are the important thing. Okay, so the function finds the keywords present in the user prompt, and it decides based on with the weightage of the keywords. Okay, so the first method which we are calling here is text to vector method. So here what we are doing, here we are passing every sentences which are there in our list, our vector db or our database. Here I'm not using database, so say assume this one. Okay, so we are converting every the inputs which we have into a vector with respect to this keywords library. Okay, we are converting every data to a vector with respect to this keyword library. What is there in this function? If we go inside, right, so here we are getting the text like file 1, file 2, each and every inputs, and this vocab. Okay, so what we're gonna do is we will create one vector, I mean we'll declare one vector here which is the size of vocabulary. Okay, the vector size will be the size of vocabulary. Okay, then what we are going to do, the each and every input which we are passing right, so we will split that into as individual words. Okay, so here text means this one. So for example, the cat sits on the floor, on the mat means the cat sits on the mat. We are splitting every word here. Okay, we are just splitting every word and taking into an array of strings. Okay, then we will just loop into the strings and find the index of the each word. Okay, each word in the given sentences with respect to this library. It's just like, okay, this one. Okay, here which is the vocab, and here this is existing library. Okay, this is existing library, this is existing library. Okay, and this will be the input. Okay, what we are going to do, we will find the words which are there in vocabulary at that particular index, at that particular index. Okay, so index vocabulary dot index of the word which we are passing. This method returns the index number of the word in the array. Okay, if the word is not there, it will return -1. Okay, so what we are going to do here, we have defined one vector array, and we'll just update that particular index. Okay, where the word is present in this our library. Okay, it's just like we are going to a library at that particular location. If we are going to that particular location where our desired book is there, we'll just mark it as 1. Okay, the same way. So here this is a library. Here we are searching the words. Okay, here we are searching the words in the library, and we are going here, and if you find that particular book, just we are mark it as 1. Okay, and wherever the other section which we cannot find that word, which, okay, we are just marking it as 0, 0, 0, 0, something like that. So this will be the vector. For example, this is the vector for first one, this one. Okay, so it's just array, a sequence of numbers. Vector means here it's just sequence of numbers here. Okay, so in the same way, we, okay, we will just append it in the every iteration and return that particular array. Fine. So like that we will do for every what do you call, so the sentences, the data which we have here. Okay, so we will get all the four vectors, and finally we'll do for the prompt as well. The prompt is this one, the user prompt. So for we'll do the same to get that vector for the prompt as well, so that all our data to be compared, and the existing data, both are in sync mathematically. So we are doing this one. Okay, so prompt and vocabulary, so we are converting all our data and prompt with to a mathematical format with respect to our defined library, right? After that we have to compare, right? As I told here, we will have to compare the prompt with every vector we got. Understood? Okay, we have to compare. So what we're gonna do is, since this is a mathematical vector thing, so we are going to do some mathematical operations like dot magnitude and the dot product. Okay, so what we're gonna do is, we will call this text to vector method 4 plus 1 5 times, right? So what we're going to do is, we will compare file 1 with vocabulary, the known sentence with vocabulary, the known sentence with vocabulary, known sentences with vocabulary, and finally the prompt with vocabulary. So here okay, sorry, yeah, here itself, the vector prompt with the prompt with vector 1, prompt with vector 2. Okay, here, so every the user prompt is compared to the obtained vectors. Okay, the user prompt is compared to the obtained vectors, means user prompt is compared to the available data in our system. Okay, and we will get one value, one numbers. Okay, one mathematical value, and that is important to give them a best possible result. So if you go inside that this thing, this cosine similarity, I mean this the function which I have defined, right? So here we want one dot product and one magnitude method. Okay, what we're gonna do is, the magnitude, like, hope you know the vector. Okay, magnitude means it's sum of all the squares of the vector. Okay, that is not about magnitude, it's easy. So for example, if this is the vector 1 square plus 0 square plus 0 square plus 0 square plus 1 square plus 0 square, so like this something, so this will give you the magnitude of a vector, of a vector. Okay, yeah, here it's like vector array. Okay, so we will find the magnitude of the prompt. Prompt means like the prompt vector array. Okay, and we will find the vector, individual vector which we have in our system. Okay, we will find magnitude of both. Understood? And we will print that. That's what we got here. Okay, magnitude. And then what we're gonna do is, we'll if you go to the magnitude, so this is a magnitude function. So here we are just doing the this thing, we'll just iterate throughout the array. Array means this one, this vector. Okay, we'll iterate through this one, 1 square plus 0 square plus, like this, and we will just take the square root of the whole sum. So this is the formula. Okay, this one for magnitude, we'll just take the square root and return that, and that will be the magnitude. And dot product, right? So this is a dot product. So dot product in vector, it will be like this is the formula for dot product. Okay, it's for dot product we need two vectors. Okay, if this is a vector a and this is the vector b, we have to take the dot product of this one, a1 b1 plus a1 plus a2 b2. So, okay, like this the first element of the first vector times the first element of the second vector plus second element of the first vector times second element of the second vector, like that. Okay, so here like 1 into 0 plus 0 into 0 plus here 1 into 0 plus 0 into 0 plus 0 into 1, like this. Okay, this will be the dot product. Okay, and yeah, here was we are not using any angles as of now, so we can just keep it as it is. Okay, this will give you the dot product. So we are just like we are getting two vectors here, right? When programmatically we'll just iterate through the array and find, I mean the, and just multiply the first element of the first vector to the first element of the second vector, plus so first second element of the first vector times second element of the second vector, like that. So, and we will continue throughout the loop. Okay, yeah, and after continuing we will get the sum. Okay, this is what here the dot product is. Okay, after that we will get it. So after that, what we are doing for to find the similarities, we are just dividing the entire dot product. Okay, entire dot product here, this will be the dot product. Okay, times individual magnitude of two vectors. Okay, entire dot product of the two vectors divided by in product of two magnitudes of the vector. So this will give me a number. Okay, this will give me a number similar to this one, like this, 0.7015, something like this. Okay, this will give me like this number. Okay, and this is what I got, final one similarity. So five, so what this tells is the first similarities. Okay, the user prompt to this file, this method, the similarities between the user prompt and the file 1 is 0.707, but the similarities between file 2, the dogs are playing and where is the cat, is 0, because nowhere the keywords are used here. Cat is not there, where is not there, right? So similarities are 0, but we have similarities for 0.7. Why 0.7? Because where is not there in the vocabulary, is not there in our library, so we will get some function. So after we getting the similarities of between user prompt and all our sentences, okay, that is a number, we'll just compare which has the more value. We'll just compare which has the more value, whether it is 1 is greater than like we have four numbers, right? We'll just compare which has more value by using simple if statement. And if which has the more value, we'll just print it as the best match is this one. If everything is 0, then we'll print there is no match at all. So that's what. So in this one simple, I'll paste this code in the comment section. We can play around, rectify if there are any mistakes or so, and yeah, do it. So this is how the works. This is a small demo, but yeah, when we are training large amount of data, right? So there will be lots of calculations and everything. So yeah, this is how it works. Um, yeah, thanks a lot. Okay.